And then we are interested to generate item sets or frequent. We're looking for frequent item set. So what we need to do first, according to the algorithm, we start to find F1, correct? If you have the slides on your side, if you go back to Apriori, so Apriori says, firstly, you start finding F1. So generate F1. So we start with having the candidate for one item set. These are the candidates. Okay. So simply you find all the unique items and put each item in one item set. And then you scan the database. The database simply is our table. And you find how many times each item has appeared inside the transaction. So for example, bread, if you count bread, how many times has shown up inside the transaction? Must be 4. So 1, 2, and then 3, 4. So we put 4. How about Coke? Coke 1 time, 2 times, and so on and so forth. Now, in order to finalize among those candidates, those we call them candidates, which ones are frequent, they must fulfill the minimum support threshold. So in order for an item set to be frequent, it has to be shown in at least 3 transactions. Okay. So looking back into the support count, bread, yes, fulfill the condition. It has shown 4 times. Coke, no. Milk, yes. Fish, yes. Diaper, yes. Egg, no. So these 2 must be eliminated. We need to take them out. So have been highlighted. Those do not fulfill the minimum support threshold. So they should be included. Excluded. That means any subsequent item set generation, they won't be part of it. All right? Because according to the principle, if an item set is infrequent, then will never see any superset must be infrequent because the superset will never exceed their support count. So even if on purpose you don't include, let's say, 2 item set, which has Coke or egg, and you calculate the support count must be similar to the support count or less, will never exceed the support count. So these 2 items must be out. Now we move on to find, now we start with the prayer principle, looking for generate the follow-up candidates, right, for L2. So now we're starting with L2. These are the candidates. So we start looking how to generate. We already discussed. So if you follow fk minus 1 with f1, that means you need to use f1 with itself. F1 with itself. By the way, those highlighted, those, and this is the frequent item set. Without them, without Coke and egg, are the f1 frequent item set. So we start generating items. So bread with milk, this is 1 to item set. Bread with fish, okay. Then we put, this should be bread followed by fish, not fish followed by bread. Anyway, it's correct, but if we follow the chronological order, bread first, then followed by fish. So if you like to take notes on your slide, this should be bread, comma, fish. And then we have bread diaper, bread diaper. Then we look to milk, milk bread, we already have bread milk. Milk fish, we add up milk fish, fish milk, correct. Then fish diaper, and so on and so forth. So we end up having, these are the candidates of 2 item sets, okay? And notice none of those item sets have Coke or egg, according to the principle, so we already eliminated them. But if you are following brute force approach, no, you would include Coke and egg in the 2 items. So you see the difference, how Apriori start, take out, so that we don't generate useless item sets. Okay. And now what we do, now we need to look for their count. So we calculate the support count, and we find now bread and fish should be eliminated because they do not fulfill the minimum support, same as fish and milk. Okay, so these 2 item sets must be out because they do not fulfill the minimum support threshold. So far, so good. Now we move on to 3 item sets. Now following fk minus 1 with f1, we already did this actually. So we should get these 4 item sets. Remember yesterday, same slide we looked into yesterday. This one, same. So we already looked how we have generated the 4 item sets, okay? If you don't remember, please see back the video. We already talked about this, how we generated these. Now, after we generated these 3, what would happen? Now we notice, of course, now when we generate the 3 item set, we don't use bread fish. So we need to use bread milk, bread diaper, diaper milk, diaper fish with 1 item set. Item set, the frequent one is bread, milk, fish, diaper. Okay, so following the slide. However, if you do this, you will find some item set you have generated. Let's see, diaper, fish milk, diaper, fish milk, you see? So there are, along the way, you have generated some item sets that have subset which are infrequent. Why fish again appears here, though we excluded it, bread fish from here. Why bread fish show up here again? Sorry, not this one. Where is bread fish? Or there is no bread fish. This one. Because of the 1 item set. Because 1 item set still has fish and milk inside as frequent. So this is why we end up having some 3 item set which has fish and have milk as well. Okay, clear why they shown up? But now we apply a prior principle. So now going back to the algorithm, what it says, we need to do pruning. We need to do pruning. If you check back the algorithm, so after we generate L3, then do candidate pruning. Prune candidates in the item set of L3 containing subset of length K that are infrequent. We already found some item set we have now generated as candidate which are infrequent, right? So now we are at this stage. Now we need to do candidate pruning. Earlier, during L2, we didn't have to because we didn't have any item set. But only on L3 now we are doing candidate pruning. Earlier, we were just doing candidate generation, support count, candidate elimination. But when we reached L3, we got some item set which are we have subset of infrequent item set. So we have to exclude. Okay, so now looking into this one, which one we should prune? Candidate pruning, diaper, fish milk. You need to find any item set that has bread fish or fish milk. So the first one has fish milk, right? So should be pruned. Take out immediately. Fish milk. And then anything else has fish milk. The last one has fish milk because they have subset which is infrequent. How about bread fish? Bread fish. This one, the second one, bread fish. Right? And we remain only with this one. So if we are doing candidate pruning, so immediately we take out these 3 item sets. Okay, we take them out. We prune them. So you don't need to calculate the count. But however, if you calculate the count, you will notice actually none of them is going to be frequent. This is to prove a prior principle. Right? If the item set is infrequent, none of its superset will be frequent. Never. Actually, even you don't need to calculate the count for these 3 item sets: diaper, fish, milk, bread, diaper, fish, bread, fish, milk. You don't need. So this also will save time to count, to calculate the support count. Okay. But however, if you calculate anyway, they won't be frequent. Okay, so you'll notice they won't be frequent. So we left only with bread, diaper, milk. And if we calculate the support count, also bread, diaper, milk will be excluded. And now F3 has become empty. We don't have F3 item set, right? We have no item set left. And that will conclude a prior principle. Because a prior principle, the algorithm says, you keep repeating, you have the loop, right? Until Fk is empty. Now Fk has become empty. No more, we don't have any item sets. So a prior principle will be terminated. And notice already written, no need to generate candidates involving cock and egg. Now notice, if you are following the brute force approach, reaching 3 item set, you will have to generate 41 item set if you're following brute force approach. But if you're following support count prayer principle, then this is down from 41 to 16 item set. So only in total, we have generated 16 item set. So a prayer principle has saved 68%, right, of candidate generation.